So good afternoon or good morning, everyone. Sorry. Welcome to this session on IoTeX and ABC MachineFi. So whereby we're going to learn through two session webinars on how to get started with Web3 whereby you're able to connect smart devices to smart contracts. So hopefully we learn a lot. So for today is more about how to set up your environment so that you're able to carry out or even participate in the tomorrow's session and be able to build the final application. With this, also for today's session, we're going to be led by Mr. Simone, who will lead us through both sessions. So Simone, welcome and take control.
Thank you, Anderson, and welcome everybody. Thank you for joining this session. So as Anderson said, today is mostly about guiding you toward what we will be building tomorrow and how to make sure, well, not make sure because we will never be sure because you may have very different systems, but try to make as much as possible you in the position where you can follow along with the webinar tomorrow. So how to configure your system the best way to try to follow along during the session. Even if you cannot make it work, I think you can still follow the webinar tomorrow because anyway, this is mostly based on a get started guide that's available on our developer portal. So you should be definitely able to run it autonomously after the workshop. So there are all the instructions included there. But anyway, this is a good option a good way to ask questions, even if you cannot follow along with the session tomorrow. But today, let's focus a little bit on what are we going to do tomorrow and how to configure your system. So this workshop is about a click and earn application. I don't know how many of you are familiar with blockchain, but this is a blockchain type of workshop. So we will use the blockchain to define a simple token economy, which is basically just a crypto token that's deployed or installed on the IoTeX blockchain. And we will use, let me go ahead with the presentation. And we will use a software that's called WebStream. And this is another network that is not blockchain, but it's intended to scale blockchain features to allow connecting data from the physical world or data from machines, from smart devices with applications that run on the blockchain. In our case, we don't have any particularly complex application on the blockchain. We have, as I said, that we only have a simple crypto token. And we want to build an IoT application that uses blockchain to reward a user for doing something with their smart device. Now, this workshop is compatible with an ESP32 board or with an Arduino board in case you really want to use an hardware to run it, but I'm pretty sure it's almost impossible to follow along on an online webinar workshop and also use hardware and also use different systems. So eventually tomorrow we will only simulate the message that comes from an hypothetical device to our system, to our application, using a web interface, but you will be able later to use an ESP32 if you are familiar with this type of boards, because also the software, like the firmware for such a board, for such Arduino boards is provided, so you can just flash it and try it yourself alone if you have any board available. So what is WebStream, how it relates with blockchain, and what are we actually going to create here. So what we will create is the basic, very basic version of what we call a MachineFi application, where MachineFi stands for machine finance. And it's similar to DeFi, if some of you are familiar with the blockchain space and the decentralized finance um, boom of applications that we have seen in the last years. So MachineFi is similar, but it's very different, meaning that it is like DeFi, so it's like applications that run on the blockchain and implement a decentralized financial token economy. But this token economy also has access to data that comes from the real world. This is a much complex um, concept because there are many like issues when trying to connect many problems and to take into account when connecting real world data with blockchain applications. And most of these problems are related to trust. So trusting the data that is going to be injected into a blockchain application, and they're also related to privacy, to storage, and to computation. But we will not go into so many details and concepts during this workshop. We'll just build a very simple MachineFi application that will have a lot of limitations, but will get you started with the concept of connecting real-world data from devices with applications on a blockchain. Sometimes I will say smart contracts. I don't know if you're familiar with the term, but the smart contract is the part of an application that runs on the blockchain. And then there is usually also a front end of an application that's at the typical web or mobile application that interacts with the blockchain. But when I say smart contract, I typically mean a blockchain application. So a MachineFi application is made of three main components. One, as I said, is the blockchain component. It's usually a set of smart contracts that run some trusted token economy on the blockchain, so on a decentralized network. Then there is a layer, a WebStream node that implements an off blockchain layer. And this layer, this node, or call it a server, right, is much similar to an IoT cloud. What it does is to connect to devices, to smart devices on one side, to authorize data incoming from devices, process this data, um, maybe implement some IoT logic that depends on our application, and finally store these IoT data uh, inside this like layer. And on the other side, this WebStream node is capable of interacting with a blockchain, so with the smart contracts, both reacting to events, so to actions that happen on the blockchain, and send actions to the blockchain when needed based on some logic. So why this is needed, right? And why we cannot use a smart device sending data to the blockchain directly. As I said, there are many issues when sending data from a device to a blockchain. And some of these are based on if and how I'm going to trust the data that comes from the device, because if my application is running on a blockchain, this means it's decentralized. There is no central authority managing and controlling the application and the software. And so it's the software that has to trust the data before running any financial oriented operation. And so just sending data to a blockchain is usually not enough. You have to do some authorization of the device, some verification of the data, and typically this can become pretty complex sometimes, and it's not possible to do it on a blockchain. But other than that, you cannot easily store IoT data on the blockchain. And you know that usually when dealing with IoT, you are dealing with a huge amount of data. And not all of these data actually is meaningful to trigger some financial action. Sometimes you have a huge amount of data, but only one single data point is the one that maybe crosses some threshold and then triggers some action on the blockchain. And so usually you don't want to store all this data on the blockchain because the blockchain is not intended as a data storage. It's expensive to store data on a blockchain. And finally, usually you cannot send data directly to a blockchain because you typically have some IoT logic, right? That can also need to use different systems, and definitely you cannot implement a complex logic inside a smart contract, inside a blockchain smart contract. That's mostly designed to implement some financial logic on the blockchain, but not IoT logic. And so that's why you need another layer, another network that whose goal is to connect machine data with blockchain applications and solving these problems of saving the privacy, storing the data, implementing complex IoT logic, authorized devices, verify data, and all these things. So this is what WebStream is. And finally, you have a third component in a MachineFi application, and that one is, of course, the device. So the firmware or the software that runs on the device, and this software typically, depending on the device, is typically collecting data from some sensors that are integrated into the device. And it could run also some logic on the edge, meaning inside the device itself, before sending some data, some insights or whatever it's sending to the WebStream node for verification, for storage, for running more high-level IoT logic. And finally, all this data from all these devices, typically they get collected inside this WebStream layer. And the goal of the WebStream layer is finally not to send data to the blockchain in reality, but to send proofs of facts that have happened in the physical world based on the data that has been stored inside WebStream. So any one of these layers has some complexities, right? But we, as I said, we will not go into too many details during the workshop tomorrow. But for those of you who are interested, I ask you to register to the developer portal and also to join our social communities on Discord to ask more questions. And also you will find me there and just dive deeper into this concept if you are interested. So this is a simple graphic that explains what I have just said, right? So you typically have, this is how a whole MachineFi application looks like. You have some devices here on the left side. You have some data. This data is injected into the WebStream layer. The WebStream layer is running some IoT logic. It's verifying the data, making sure this data is actually coming from the right device, storing this data. And then you have some blockchain applications, and this actually, the application can run on any blockchain, not only IoTeX. And you have blockchain applications that at some point they need to receive some proof that they can trust before they can run some token economy. So in our example, we want to, our device is just a simple device with a button. We want the user to click this button, and our simple IoT logic running on WebStream will just count how many times the button has been clicked. And every 5 clicks, we want to send a proof to the blockchain smart contract so that the smart contract will send 1 token reward to the blockchain wallet that is indicated inside the message of the device. So our device will, every time you click the button, it will send a message to WebStream. This message will include a blockchain address, and WebStream will store how many times the button has been clicked, and every 5 times it will send a proof to the blockchain smart contract to say, hey, send 1 token to this account, and the account is actually included inside the device message. So this is how our simple application works. I will skip this one. So this is like a zoom view inside what's a WebStream node, what is inside a WebStream node. And we will go through these details tomorrow. but it's pretty simple. You basically have just inside the WebStream node, there is a virtual machine that can run some logic. This logic can be developed using any high-level language and compiled as a WebAssembly module. And then the WebAssembly module is installed inside the WebStream node. And the WebAssembly module contains the logic, right, that I've just been talking about. But for this logic to run, you have just to set up some events inside the WebStream node. And these events just tell the node what logic you want to run depending on what happens. And typically what happens is just that some data has been received by the WebStream node on one of the endpoints. And so what you want to do, you just set up all this strategy where you say, okay, when I receive some data, if this data contains this event, then please run this code inside the WebAssembly module or run this other code, this other function in this other WebAssembly module. And then the function will do whatever your WebStream node wants to do. For example, count the number of messages or execute a blockchain transaction. But tomorrow we will go more into the details here. So just let's get started with some information for you on how to make sure you will be able to run this node. So getting back a little bit here, the IoTeX, we will use the IoTeX blockchain to deploy a token contract. Actually, I will deploy the token contract. What you will want to do is to run the WebStream node on your side. And then you will simulate sending a message from a device to this node. And you will configure the node to count the number of messages and to send a transaction to the IoTeX blockchain to the smart contract that I have deployed that defines this token logic. And so that the smart contract will actually mint a new token and send it to the blockchain wallet that you have set up your WebStream message. So what we want to do today is just to make sure that tomorrow you can run this WebStream node. So what we do, we go to the IoTeX developer portal first. So let me actually do it live. So you want to go to the IoTeX developers portal at developers.iotex.io, and you can access my developer profile on this website, and which is developers.iotex.io/user/Simone Rom. That's my username on the developer portal. So in my profile, I've created just two documents here. By the way, you can do the same if you register a developer account on the portal. That, by the way, you have to do to run this workshop. So I've created two documents here. One is how to run a WebStream node on Windows, and the other one is how to create a developer account, an IoTeX developer account using the Metamask wallet application, and how to get some tokens so that you can start working and get started with creating blockchain applications. So in terms of how to run a WebStream node, we have a great documentation at docs.webstream.com. And here, how to run a node, there are all the instructions how to run a node, right? So these instructions apply to macOS and Linux. Windows is not directly supported, but you can run it by installing the Windows subsystem for Linux on your Windows system. It's called WSL. Right, there are instructions on the Microsoft website how to do it. Anyway, I've collected this information in this document here run WebStream on Windows. So as I said, you go to the IoTeX developer portal, developers.iotex.io, find my public profile with /user/Simone-ROM, and then you find my contributions here and just open the run WebStream on Windows. So I've tested this one on a Windows computer. It seems to work pretty well. So if you have Windows, you should be able to follow these instructions. Let's go through them very quickly. So the first thing you want to do, you will install WSL, right? This will also install basic Ubuntu system inside your Windows computer. Then inside this Ubuntu Linux, you will install Docker because WebStream can be run as a Docker image, so it's very simple to run it. You don't have to install anything, only install Docker. And finally, once you have the Docker installed, you can just pull and run the WebStream Docker image in one single command. So in my case, I used Windows 10, I think, but it should work also with Windows 11. So what you want to do, you just open a terminal in your Windows computer. Make sure you just right-click on the command prompt or on the PowerShell of Windows and select Run as an administrator, so that you will open a command prompt as an administrator on Windows, and then you will run this command, WSL-install. This will start installing the WSL system. It does not take much, I think several minutes. You could even try to do it now if you want. And at the end of the installation, it will ask you to reboot your system. After you reboot, it will complete the installation, and also it will install the Ubuntu system inside WSL. So at the end, you will have inside your Windows menu, you will have an Ubuntu icon and an Ubuntu application. So you can just click it and this will open the command prompt of Windows, but it will be open as a Linux system. And so from this point on, both if you are using Windows or if you're using Linux, and even if you're using macOS, more or less the installation is the same. So basically you have to install Docker. Installing Docker, I've linked the instructions here, like the official instructions on how to install Docker, which are, basically, I've linked the ones to Ubuntu, but if you have different systems, you can just follow the different install instructions here. So I've just collected here the short instructions that we need. So how to install the required packages, and finally you install Docker, and you add your user to the Docker command, to Docker group, and you will have to restart the Ubuntu terminal, and finally you will be able to test that Docker is working correctly in your system by running this hello world. Pull and run the WebStream node. So basically this is the command to pull and run the WebStream node. You can also do it into two different commands. I suggest, actually, let me edit this article live. So here, I suggest that you first create a folder inside your system, call it, I don't know, mkdir docker, and then enter this here. this directory. And then you will first fetch the Docker configuration. And then after you have fetched the Docker configuration, you will be able to, you will be able to run the WebStream node with this command. So if it's running correctly, then you should be able to open a browser and just type https / localhost 3000, and you should be able to see the WebStream login web interface. I'm not sure if I have one running here. I think so. Localhost 3000. So I have already a WebStream node running on my computer. So I see the WebStream Studio login interface here. There is the default password and user. So just click login and you will see the WebStream Studio interface ready for you to start configuring your WebStream node. So this is for what regards the how to get the WebStream node running, right? But as I've said, you will also have to deploy some logic inside the node. And so there are two options. You can either just follow along with the webinar and deploy the logic module that is already provided. Or you may want to actually modify the logic and customize it. And that's probably what you want to do if you want to run it successfully. So if you want to modify the logic, so let's first see where this logic is, right? I go to the developers portal, and this one, the purple one, is the actual project that we will use, the click to earn example. I see there is maybe a question. Let me see. Angela?
Hello. Yes, hello.
Hi.
Good morning.
Hi, good morning.
I wanted to ask, does IoTeX support a script like as the programming language?
Which programming language? Which one?
A script.
A script. You mean EM script? This one?
SCR. It's SCR.
S
Y.
C. Oh, let me.
CR.
S.
CRY.
CRY. Oh, sorry, I can.
PT.
Okay, let me actually clarify the language. So, are you talking of the blockchain language or the WebStream language? Because the blockchain language is the language that you use to create smart contracts on the blockchain. And because IoTeX is compatible with Ethereum, you can use Solidity for the smart contract. So Solidity is the language that you can use on Ethereum and also on IoTeX to create the smart contract. There are also other languages that Ethereum supports to create smart contracts and also IoTeX, but typically Solidity is the main one and the most documented one. This is for the blockchain side. For the WebStream, so talking about WebStream, so here is where you implement the logic not on the blockchain, but inside the WebStream network. And this logic is usually an IoT logic. And it's like you program this logic into using two components. One component is the actual software, so the actual logic. And this logic can be created using WebAssembly. I don't know if you're familiar with WebAssembly. Have you ever heard of WebAssembly? Oh, I think, Angela, you muted yourself. Sorry. Okay.
No, I've never heard of WebAssembly. Actually, I was in Bitcoin development,
Mm-hmm.
and we are using a script. So
Mm.
I had some idea and I wanted to integrate in some IoT.
Mm.
So I thought there is some compatibility between the IoTeX and the script because I was in Bitcoin development.
I see.
Yes.
I see. Mm. No, I'm not. I myself, I'm not familiar with with Bitcoin development, but definitely IoTeX is fully compatible with Ethereum. So the development happens in terms of smart contracts. So you usually create a smart contract using Solidity, and then you deploy or you install this smart contract inside the IoTeX blockchain, and then you execute the smart contract by calling smart contract functions from your client application. And typically you use the smart contracts to create custom tokens, for example. That's the most typical use of a smart contract, but you can make it as complex as you want and create complex applications like decentralized finance, lending, borrowing, or liquidity pools, or games, NFTs, and all these things that you can create on an Ethereum blockchain. And in this case, we use the blockchain for what it's mostly designed for. So for the financial part. So we just create a custom token that we will call it click token, and we use it as a reward token. So this token will be sent to some address when something happens. And what something happens, usually you define what to do inside the WebStream node. And inside the WebStream node, you can program the logic as I said, in two steps. One step is you create the logic as a WebAssembly module. To create the logic as a WebAssembly module, you need a high-level language that can compile WebAssembly modules, that can be compiled into WebAssembly modules. And typically there are a lot of these languages. You can use Golang, you can use C++ if you're familiar with it. You can use Rust if you're familiar with it. And in terms of a simpler language, there is assembly script, which is very similar to TypeScript, but it's designed exactly to compile WebAssembly modules. So usually you create your logic in one of these languages, uh, and then you compile the logic. So let's say you use Golang, right? If you use Golang, then you can import any library, any module that is supported by Go, and then you can implement your logic. When you implement your logic, you will also use some uh, functionalities that the WebStream node makes available to you. For example, accessing the data that has been received from a device, as well as will allow you to interact with the blockchain. Plus, you can import any library that you want and perform any complex logic that you want. And finally, you will compile the WebAssembly module and you will install the WebAssembly module inside the WebStream node. We will go into these details tomorrow. But since we are talking about it, let me mention the last step of configuring your system, which is installing an actual language that you can use to compile a WebAssembly module. So I will use Golang because the quick start that we have on the developer portal uses a Golang example. And so here is the repository that we will fetch tomorrow, we will clone tomorrow, and inside this repository there is the source code of our very simple Golang logic. So to be able to compile the WebAssembly module, you will have also to install Go in your system. I also tried this on Windows, so of course it works on Linux, it works on macOS. So you just go to the Golang website, go.dev, and installing it, it's very simple. I've tested it also in Windows using the WSL. So inside your WSL terminal, you just download this file here. You can do it this way, just copy the link. I will add these short details also to my document before tomorrow. So you can just do wget, so webget the link and just download it, right? Depending on your system. And then depending on your system, I am on a Mac, but you will select Linux, both if you are on Linux or if you are on Windows WSL, and you just do wget this file, and then you just execute this command here as an administrator. And this will install Go in your system. And after you have installed Go, Go is not capable of compiling WebAssembly modules directly. You will have to install another little utility, which is called TinyGo. So if you search for TinyGo, this is very simple to install. Quick install guide here. You will follow the Linux guide and Ubuntu, right? It's this one. So you will just fetch the file and just install it in your system. And that's it. You will have TinyGo and Go installed. So just to recap, if you are in Windows, you install WSL, you complete the installation of WSL, and then you will have a Linux and Ubuntu terminal ready for you to work with. Then starting from an Ubuntu terminal, you will install Docker. And after you have installed Docker, you should be able to just run a WebStream node immediately with a single command. And then when you have tested that WebStream is running for you, you will go ahead and install Golang on your system and then TinyGo on your system. And you should be ready to go with running a WebStream node and modifying or creating a new WebAssembly module and then deploy it to the WebStream node and then start configuring it and doing everything that you want to do with it. And this is one step. The other important thing that you want to do before starting building is to create a blockchain wallet, right, on the IoTeX testnet. So what does this mean? I've created another document here called Create an IoTeX Developer Account. This collects some information on what you need to get started with like interacting with the blockchain and deploying smart contracts, even though you may not do it tomorrow, but if you want to follow along with what I do, you could even try to do it. You will need it also to configure WebStream. So what you are going to do here, as I said, we will deploy a token, a custom token smart contract on the IoTeX blockchain. But as for any blockchain development, we will not start building on the IoTeX, on the real IoTeX blockchain, because the real IoTeX blockchain requires real tokens with real value. And usually you don't want to pay real money when you are testing and debugging and just developing and finding bugs in your application, right? So usually you use the testnet, which is just a clone of the actual mainnet, so of the actual blockchain, the real blockchain, but it's just intended for development purposes. So this means that on the IoTeX testnet blockchain, you also have the IoTeX token, just it has no value on the market at all. And you can get usually as many as you want of these test tokens, and then use them to deploy your smart contract, test it, and without spending real money on it. So to do this, you will need first a blockchain wallet, meaning an address and a private key of a blockchain network that will allow you to send transactions to the blockchain. But before you can send transactions, you also need to have some test tokens, some native tokens actually. That's the token that blockchain use to allow you to send a transaction and pay a fee to the blockchain for sending this transaction. So on the Ethereum blockchain, the native token is ETH. On Bitcoin, the native token is BTC. On IoTeX, the native token is called IoTeX. So if you want to send transactions to the IoTeX blockchain, you will have to pay a fee in the IoTeX token. And so if you're using the IoTeX testnet blockchain, you will need some IoTeX tokens on this testnet blockchain. And I'm showing you how to do it. The first step is to install a blockchain wallet application in this case. These applications usually help you create a blockchain wallet. A blockchain wallet is only a random private key that is used to sign blockchain transactions. So it's not a good idea to invent a private key by yourself. So that's why you use a wallet application. So the most popular wallet application for Ethereum blockchains is Metamask, which I've already installed. You can install this as a plugin for your browser. You need a Chrome-based browser. I'm using Brave. You can use Chrome. I think there is also one for Firefox. So you install Metamask. It's available at metamask.io. Metamask.io. You just download it for your browser and install it. After you have installed it, you have to complete the configuration of MetaMask. And this means basically saving a set of 12 words that it gives you to back up your wallet. So you just save these words inside a notepad or somewhere in a safe place. You write them down if you want. And then you complete the installation of MetaMask. And this will give you a blockchain wallet, right? This is the address of your blockchain wallet. And this application, what it's doing, it's just storing safely the private key of this wallet so that you don't have to care about it. And it will allow you to sign a transaction and send a transaction to a blockchain. What blockchain is MetaMask sending the transaction to? It's up to you to decide. By default, it will send transactions to the Ethereum blockchain, but you can configure MetaMask to send a transaction to other blockchains, for example, IoTeX. And because we want to use the IoTeX testnet blockchain, you will have to add the IoTeX testnet configuration to MetaMask. I've already installed it, but let me actually delete it so to show you how to add it. So I'm switching to a different one. Sorry, let me switch to a different one, and then let me delete. I wish I could delete. I will delete the IoTeX testnet. Okay. So if you want to add the IoTeX testnet blockchain to MetaMask, you go to the developer portal again. You go in the utility menu and you select add IoTeX testnet. And then you click add IoTeX testnet configuration. And then it will just send all the configuration of the IoTeX testnet blockchain to MetaMask. So you just approve. And then it will also ask you to switch to this network. So at the end, your MetaMask should be connected to the IoTeX testnet. Here is where you select which blockchain you want to send your transactions to. So we select the IoTeX testnet. And once you have selected the blockchain, MetaMask will show you the balance of the native token of this blockchain for your account. In my case, I have a 100, you will add 0. But you need some test tokens if you want to work with the blockchain. So how to get some test tokens for IoTeX? It's very easy. Let me show you. So when you log into the IoTeX developers portal, you will have to sign in using your GitHub account. I have already signed in before, so it will not ask me anything. In your case, it will ask you to log in with GitHub the first time. At this point, you have your profile page here where you can go to the dashboard. And inside the dashboard, you have the ability to connect your MetaMask wallet to this website. So I click connect, and it will connect my wallet to the website. As you see, my wallet is this one, starts by 0x00E, and it's connected here with the website 0x00E. It tells you the balance on testnet, on the testnet blockchain. And if you want, you can, well, I cannot do it because I've already claimed some tokens before. You can only claim tokens every 24 hours, so I cannot do it. But you will have like a claim test tokens button here. So if you click claim test tokens, it will send you 100 test IoTeX on the IoTeX testnet blockchain. So once you have your MetaMask configured, you have your IoTeX developer account, you have claimed some test tokens, then you are ready to get started and build applications on the IoTeX blockchain. One more tip I want to give is this one. You will need to know the private key of this address, because we will use it. We want to use this account to send transactions from the WebStream node. So we will have to configure our WebStream node with the private key of this address so that WebStream will be able to sign and send transactions on behalf of this address, because that's the one where we have the tokens, right? So if you want to show the private key of this address, you just go here on the three dots, you click account details, then you click export private key, you input your MetaMask unlock password, and it will show you the private key, which is just a long hexadecimal string. And when you have the private key, you can save it in a file just to have it at hand to configure WebStream. Of course, this is for the IoTeX development testnet. So usually you don't want to export, you don't want to copy paste your private key anywhere. Typically, you usually, when you have done the backup of the MetaMask wallet, when you install it with those 12 words, you are fine, and you can recover your account at any time. But the private key sometimes is needed during development to configure different frameworks or clients or libraries to send transactions to a blockchain. So one last thing, by the way, we are recording this session, so I will share the link to the recording with Anderson so that you can rewatch it. So one last tip I want to mention regards the WSL. So if you are on Windows and you have installed WSL, I don't have a Windows computer connected at this moment, but let's pretend this one is the WSL terminal that you have on your Windows computer. I just want to mention that you can open any Windows application from the Linux terminal. So typically, if you are inside a folder, for example, let's pretend you have cloned the click to earn example, and you want to start editing the source code. If you have Visual Studio Code installed in Windows, you can just start Visual Studio from your Linux terminal in Windows by typing code dot inside the current folder. That's why I said dot. So if you type code dot in your Linux terminal, in Windows, it will start VS Code normally inside your computer. Another tip, if you, for any reason, want to access the files of your Linux subsystem in Windows, and you don't know where these files are, you just enter your home directory, right? Still pretending that I am on Windows, right? But the commands are the same. So if you are in your terminal, you can run explorer.exe in the current folder. This will, I cannot do it because I'm on macOS, but if you do it on Windows, this will start the Windows Explorer inside your Linux folder, which is something like, I can't remember, but it's a network path. So it will open Windows Explorer, and you can also copy the path, and if you want, you can use it to create a shortcut on the desktop. If for any reason you want to explore the folders where your Linux subsystem is storing all the files. I did not need it, but just in case, this is a tip for you. Any other things I want? Oh, all these instructions are again inside my public profile at developers.iotex.io/user/Simoneron. In this document here, create an IoTeX developer account. And here I'm just showing all the steps, how to add the IoTeX testnet to Metamask, create an IoTeX developer account, fund this account with some test tokens, and then how to access the private key. Okay, so I think I've shared everything. I see there are some questions here in the chat from Azante Ntiro. Sorry, I cannot pronounce your name. The question is the WebStream logic written in Golang or WASM? Good question. So the WebStream logic is executed in WebAssembly, but you don't have to write the WebAssembly directly. If you enter, let me show you how it looks like, right? If I enter the click to earn folder here that I have inside the get started, or if you want to start getting started ahead of time, you can clone the get started that you find here. On developers.iotex.io, you click on deploy MachineFi application, and then you can, this is what we will go through tomorrow, right? So if you want to take a look, it's here. So if you clone the get started, you will find this folder here. And inside this folder, there is another folder called WebStream, where there is the actual logic of WebStream. So inside the source folder, there is the Golang logic. So I can open this folder inside VS Code just to show you, right? So in the source folder, I have the actual logic written in Golang, okay? And that's just this function that is called start, right? So this is my logic for the WebStream node, but WebStream cannot run Golang, right? Because there are no Golang interpreters out there. So you have to compile this logic, and because WebStream uses a WebAssembly virtual machine, you have to compile this logic as a WebAssembly module. A WebAssembly module can be executed by a WebAssembly machine or virtual machine. Typically, there are no hardware machines for WebAssembly. Much similar to Java, right? You have Java, you write in code can be executed by a Java virtual machine. And this is more or less same. You have this Golang high-level language, you compile it and you compile it and, or let me make it a bit bigger. When you compile the Golang, you get the WASM file. This WASM file is the actual WebAssembly. You can also take a look at what's inside the WASM file. But usually you don't want to, oh, not the WASM, because yeah, this is already machine code. This is already bytecode, so you cannot display it. But there is a WASM text mode that where you can actually see what's inside the WASM. It's just changing the bytecodes inside the corresponding short version in text form of the command. But anyway, that's kind of an executable file. And that's what the WebAssembly machine can run. You can get this file, this executable, using different high-level languages. We are using Golang here, but you can also use C++, or you can use assembly script, or you can use Rust. You just write the logic in one of these high-level languages, and then you compile using a WebAssembly compiler, and you will get the corresponding WebAssembly executable. And then the executable can be executed inside WebStream, because WebStream implements a WebAssembly virtual machine. That's why I told you to install TinyGo. TinyGo is the Go compiler that can target a WebAssembly virtual machine. So when you compile using TinyGo with this command here, you can build a WebAssembly module out of your Golang source code. And there are similar compilers for different languages. So the high-level language is your choice, but eventually you will have to compile as a WebAssembly module to be able to install it into your WebStream node. I hope I answered the question. So let me unmute Anderson.
Thanks a lot, Simone. Really appreciate introducing us to this session. Looking forward to tomorrow's session where we'll be able to build the application in full. I'll share the links as well. So when you get the recording, I'll be able to share with the team as well so that they can be able to review and even prepare prior to tomorrow's session.
Okay.
I see there's another question, I think, before we close.
Yeah, Isaac is asking if we can use Python instead of Go. So there are many languages, high-level languages, that can compile to WebAssembly. I think also Python. The problem is that WebAssembly has been designed to be executed inside a browser, like the JavaScript virtual machine. So while there are a lot of languages that can compile to a WebAssembly module that can run in a browser, we are not really using a browser inside WebStream. Instead, we are using a different WebAssembly virtual machine, which is called WASI. WASM. WASI is like similar to what Node.js is for JavaScript. Node.js allows a JavaScript code to run outside of a browser. And WASI allows a WebAssembly module to run outside of a browser, inside, for example, a virtual machine like in WebStream, where we are not executing the WebAssembly code inside a browser. We are just executing the code inside the virtual machine, and the code does whatever we want it to do, but it's not definitely running anything inside a browser. So this WASI machine is a different target, is a different machine than the actual WebAssembly browser machine. And so not all the languages that can compile to WASM can actually compile to WASI. And the ones that I've mentioned work. So Golang, C++, Rust, and AssemblyScript. Other languages, so far as I know, they do not support the WASI virtual machine. You can maybe try to search Python WASM WASI and see. But as long as I know, Python cannot compile a WebAssembly that works for the WASI virtual machine. Or maybe yes. Anyway, yeah, maybe yes. I have not searched actually, and this WebAssembly is also a very new language, so it's changing pretty quickly, and there is a big community of passionate people around this new technology. So definitely interesting to do some search. As long as you find a language that can target WASI, then you can use that language and run the WebAssembly inside WebStream. Okay, so Anderson, your question is, how can the audience generate revenue from such model solutions like the one we will develop tomorrow? So there are two types of revenues here. One is the builder and one is the user. So the builder, in this case, you are the builder. So you are the one who is developing the MachineFi decentralized application. So for example, if you are a smart device manufacturer, right, then you are creating a smart device, for example, a weather station. And this weather station is sending data to your WebStream node. The WebStream node is collecting all this weather data. And then you have a blockchain application that implements some token economy, for example, where other blockchain applications wants to use the weather data, right? Because maybe they implement, I don't know, a weather data exchange, I don't know, or they implement trading weather data. There are some trading weather data applications out there where you can, for example, for insurance, right, where you can somehow buy some tokens that represent some weather data, and if that weather like somehow you can use it to make some insurance based on the weather that will actually happen in the future. So if you're building this weather station, then you are building the entire MachineFi application that collects the data from this weather station, and then you implement the token economy on the blockchain. And then you also have your own token, right, that is used to reward users that contribute data using your weather station. And so you are the designer of the MachineFi application in this case. So you will earn with whatever model you have designed for earning, right? For example, you could take a fee of all the transactions that happen inside your smart contract, right? So this will be your earning as a builder. Then there is the earning for your users, because if you want to earn as a builder, you need users that use your system. And in your case, in the example of the weather station, there will be people that want to buy your weather station because they know that if they buy it and they just install this weather station, they will start earning rewards from your token economy. And so that's how your user will earn rewards, by using your device and using your system. They will earn some rewards, and where these rewards come from, they come from other people that are buying this weather data inside your system. So of course, this is a fairly complex type of MachineFi applications, but this is what connecting real world data with blockchain applications allows, right? Or it could be something different, like the click to earn is just an example. It's not a real application. Nobody is interested in earning rewards for clicking a button. It's hard to think of an actual application, right? But this click itself could represent anything in your device. Could be a door that opens or closes, or could be something more complex. For example, we have another demo which is called walk and earn. If you can prove that you have walked 10 miles every day for 1 week, then you can earn rewards from a smart contract. So you could build such an application, such a MachineFi application. And if you are the builder, you will earn rewards based on whatever model you have decided in your application, based on fees or based on monetizing your devices, right? Maybe you just want to monetize selling devices. But people that use the application, they will be able to use your device and connect it to your application and then start earning rewards for walking 10 miles every day. And again, where these rewards come from, where the value of these rewards come from, right? It's not that I create a token and it has any value. So in this case, it could be different use cases. For example, the value of the token could be if this application has been created by a smart city administration, right? Then the administration may want to incentivize citizens to live a healthy lifestyle. And so the smart city is rewarding users for having a healthy lifestyle. And so if I can prove I'm walking 10 miles every day, then I'm getting these rewards from the smart contract in this system that the smart city has deployed for their citizens. And then these tokens, maybe I can use them to claim some benefit inside the smart city. Inside the smart city, for example, I can pay less taxes, or I can use them to pay taxes, or I can use them to buy tickets to museums, right? So in this example, the smart city would allow the citizens to prove that they are living a healthy lifestyle using a device that is sending this data to a WebStream node. And then the WebStream node could feed these proofs to a smart contract, where the smart contract is then sending the rewards to the users based on their activity. And this could be a system deployed by a smart city administration, for example, but could also be deployed by a company. If the company wants to their employers to live healthy, or if they want them to sleep 8 hours every night, so that when they go to work, they are fresh, refreshed, and they can focus on their work. And so the company may want to reward their users with token, and this token could give them some benefit inside the company. For example, I don't know, more payoffs or whatever benefit. So yeah, how to earn, it depends if you are the user or if you are the builder. If you are the builder, usually you have a token economy designed and you are getting some earning from your own token economy. While if you are the user, then you are typically earning from using the application. So getting the rewards or getting paid for whatever MachineFi utility you are providing. A long answer, sorry.
Yeah, thank you so much. That was very insightful. I think now people can be able to think in terms of how they can apply several instances of IoT with the blockchain. They can start thinking of projects that can come.
I want to just add one more thing, because it sounds a little bit very complicated, because it is complicated to create a full end-to-end MachineFi application, because it requires hardware. And also this hardware should be trusted, because you don't want people to send fake messages, right, to your application and just drain all the tokens that you want to send as rewards. So it's not easy. However, there are two ways. Either you really want to build a device, right, or you are using an existing device. So we have, for example, deployed a first WebStream application which uses smartphones to send location data that is trusted already, meaning that we have created the mobile application and also the SDK if you want to create your mobile application and allow it to send trusted GPS location. Then we have the WebStream node that receives this GPS location from our application, verifies the data, making sure that's actually location, real location coming from our SDK, from our application, so that it's not fake data. And then the WebStream node is storing this information, this data. And then you can create directly a blockchain application that is based on this GPS location. So you don't have to think of how to generate this data, how to make it trusted. You can use, this is another example of MachineFi of what you can build with WebStream. We have built it, but other companies can build similar applications. So once we have built it, this model where you can fetch this trusted GPS data and use it inside smart contracts. For example, we could earn by asking for a fee every time you want to verify, you want to fetch this GPS data. Yeah, this is more, we go more into the real applications here, which is maybe too complex. So one step at a time. This workshop is only intended to get you started. So for interested people, that there is quite a lot to study, by the way. Oh yeah, we have a nice website around WebStream, webstream.com. You may also want to take a look at the white paper here. This is a high-level white paper, but it introduces you to all the concepts behind a MachineFi application. If you really want to start studying about it. Okay, guys, that's all on my side. Anderson, I'm muting you. Okay. Oh, sorry. Again.
Yes, okay. That's perfect. Thank you so much, Mr. Simone Romano. And thank you everyone for participating in the webinar. We're looking forward to tomorrow's session, and kindly also urge other people to join in so that we can learn together.
Cool.
Otherwise, thank you so much. Do have a wonderful afternoon.
You too. Thank you, guys. See you tomorrow.